The ones that I have here are dark blue and red. Okay? The ones in your textbook, they use green and white. And we don't call the big squares Fred. The big squares are x squareds. The little squares are ones. And the rectangles are x's. Now, if we wanted to get fancy in these, the reason they're called this is because of area. If you have one here and one here, the area of that square, length times width, would be 1. Okay? And if this side is x and this side is 1, the area of that rectangle, length times width, is x times 1, which is x. And these bigger squares have the same lengths as the rectangle. They're x and x. The area of a bigger square would be x squared. We have one in one color for positive, one in the other color for negative. Okay? And a positive and a negative, they would cancel each other out if you were adding. So these are Algetiles. And with our algebra unit, sometimes it's easy to think about what we're doing if we're using these diagrams. Like, for example, when we started off with 2 liams, and I added 2 more liams, then Luke had no problem saying, I now have 4 liams. But now we're going to think if I have 2 x's, and I add another 2 x's, I'm going to have 4 x's. That's the algebra part. Okay? So we start off, first of all, knowing what things are. Knowing what's positive, what's negative. I actually wish that they made the little one green, because in the ones that we have, all the red ones are negatives and the blue ones are positives. But then they switch the colors here. But in your textbook, all the white ones are negative. And for your exam and for your test, your formula sheet has the Algetiles on them. So, this says write an algebraic expression for the quantities illustrated. So the whole reason we did that activity at the beginning was for you to get used to naming things. Right? At the beginning, Luke called the tall, skinny ones liams, and he called the little squares eunuchs. So you would say you have 2 liams and 4 eunuchs. But now, we're going to say, in Algetiles, what do the long, skinny ones represent? X's. So I have 2 x's. And what do the little squares represent? Negative 1s. And how many negative 1s do you have? 4 of them. So we would say the expression for this is 2x minus 4. It's always good to review our definitions. What number is the coefficient?
4.
Close. 2. Coefficient, number in front of a variable. What's the variable? X. What's the constant term?
4.
Negative 4. So when the constant term is the one all by itself, but if there's a subtraction sign in front, we would say the constant term is a negative form. What kind of polynomial is this? It is a binomial. Okay, let's look at our next one. What are the skinny ones? Negative x's. So how many negative x's do we have? 3. Negative 3 x's. The little ones are? Plus 1. How many do we have? 6. Negative 3x plus 6. Okay? So part of this is just recognizing if you give something a name, and we name the little boxes 1s, and you have 6 of them, would it make sense to say you have plus 6? Okay? So try this third one. Okay?
Hey, Mr. Roth, I already completed it.
Perfect. Here's an example. Okay? This is the question we're on. This is an easy question if you're here. Would everybody agree if you were not here for the first part of class, this question would be impossible for you? Yes. Like this is a good example of if you're not here, the question becomes impossible. The answer to this is 2x squared minus 3x plus 1. And it is a trinomial. Okay? Again, as we get into the math that we're doing, it's actually not bad, but you have to be here in order to understand it. So 2x squared minus 3x plus 1. Perfect. Okay, your job on the next one is to draw. There's 4 examples there. You read the words, 3 less than twice x, and you draw Algetiles, and you can write the mathematical expression as well. You can decide what you want to do first, draw the Algetiles or write the mathematical expression. So, couple things here. When I see twice x, I think about 2 x's. And 3 less, I would subtract 3. As far as drawing that goes, my x's are my rectangles, shaded in because they're positive, 2 of them. So we always shade in for positive when we're drawing. And minus 3 would be 3 squares that are not shaded in for the negatives. In math, when you say opposite, what's the opposite of 5? Negative 5. Opposite means negative. So the opposite of x would be a negative x. How do we draw a negative x?
Negative x.
That's a long rectangle that's not shaded in. The sum of the opposite of x, okay, opposite of x is a negative x, and it's a sum. Is sum adding, subtracting, multiplying, or dividing? What does the word sum mean?
Multiplying.
It's not multiplying.
Adding.
It's adding. Sum is adding. Opposite of x plus 2. So when we draw this, there's our rectangle for x, not shaded in because it's the negative x. And then 2 those would be shaded in. 4 less than x squared. So x squared would be this. 4 less, would you add, subtract, multiply, or divide? Subtract. So there's our expression. How do we draw that? X squared is the big square. Shaded in. 4 less. Four little squares. Okay? So one of the things that we're doing here is we're translating from the English to the math expression, and then our math expression showing it in the pictures how we've named things. X squared is the big square, 4 less. Okay? So it's not hard if you remember the names, right? It is hard if you decide not to remember the names. So this is something that you're going to have to, again, in your 10 to 15 minutes tonight, in your review, I would say a good thing to review tonight is what do the different Algetiles represent? Okay? Should I put a bonus on the quiz? What were the names that Luke gave each of them? Yeah, that would be good. Luke would remember. Would you remember? What did he call this one? Fred. What are these ones? Okay, and the... See? If you can remember the crazy names that Luke gave for them, it's just a matter of making a decision to remember which one's x squared, which one's x And there's A and B if you want to look at them again. Now, the reason that we introduce the Algetiles is to help us with simplifying. So here we have an algebraic expression that says 3x plus 2 minus 5x plus 7. Do the Algetiles make sense in the picture? Can you see 3 x's plus 2 minus 5 x's plus 7? Okay? Now, these shapes are alike, and these shapes are alike. But what happens when you have something and its opposite, and you put them together? 5 and negative 5? 0. What about 3 and negative 3? 0. So x and negative x make 0. So whenever we have the same ones, we can say this one and that one would cancel out, because that would be 0. This one and this one would cancel out. That would be 0. This one and this one would cancel out.
0.
So if those ones are all gone, oh, what are we left with?
2.
Okay, let's write the answer to this. How do I write this? What am I left with? Negative how many x's?
2.
Negative 2 x's. And then, what do I have here? 9.
Oh,
Those ones are the same, so they wouldn't cancel out. You have negative 2x plus 9. Okay? Now, eventually, you won't draw the Algetiles. Eventually, you would want to go right from this to your answer. And the question is, can you see that you could get the 9 because you have a plus 2 and a plus 7? Would you agree that 2 plus 7 is 9?
yeah.
Does that seem like you could do that without having to draw 9 little squares? Okay. Now, I have minus 5x and a 3x. Could you get minus 2x from that without having to draw all of those rectangles?
Yes.
Because if you took 3 and you subtracted 5, you would get negative 2. And so what I've circled there, those are like terms. That was, I said, a very important definition that we had the other day, the idea of like terms. Because if things are alike, you could put them together. Right? When I added 2 extra eunuchs, or whatever they were called, right? Luke right away said, oh, now I have 9 eunuchs, or 7 eunuchs, or however many we had. He had no problem saying that. He didn't introduce, oh, I brought in 2 more. He's like, didn't introduce a new name, like Bartholomew or something. He just said, now I have 9. So when we have things that are alike, we can add them. And so at the beginning, you guys were doing algebra without even knowing you were doing algebra, because it's that idea of adding things that are alike and subtracting things that are alike. And this, what we did when we combined like terms in algebra, is called simplifying. It makes sense if you have 2 here and 7 there that you really have 9. 9 tells us exactly what we have right away. (5x plus 2x plus 6x squared). If that's an x, 1, 2, 3, 4, 5 x's. Agreed that that's 5 x's? And then it says plus 2 x's. So there's plus 2x's. And then it says plus 6x squared. X squared's the big one, shaded in. And I have 2, 3, 4, 5, 6 of them. That's drawing it out. In total, if we look at it, what do we have? Right? If I gave you just the drawings and you told me, well, how many do you have? Would you agree that you would still say, I have 6x squareds? Yes. How many x's would you tell me you have? 7. And so this one and this one are like terms. Could you do that without having to draw all those pictures? Yeah. Right? You're probably going to like doing it without drawing the pictures because it takes so long to draw the pictures. That it would be easy to say, oh, if I have 5x plus 2x, how many x's do I have? I have 7 of them. But the whole reason we draw the pictures is because lots of students will want to add the 2x and the 6x squared together. But they're not alike. That's a big idea in algebra. In order to be alike, you have to have the same variable with the same exponent. Okay. Oh. And then I've got in yours, remember to be like terms that the exponents and the variables have to be the same. So we only have pictures for x's, but that doesn't mean we can't do algebra if we switch the letters or if we switch the variables. So here I have 5ab minus 8ba. The first thing you have to decide, are these alike or not? They are. Because in order to be alike, you have to have the same variable with the same exponents. Do they both have an a and a b? Yes. And they both don't have, well, they have an exponent of 1, but it's not written. So this question ends up being a question we did at the beginning of our rational numbers unit. If you had 5 and you subtracted 8, where would you be on your number line? If you had 5, right, you can draw out your number line. Here's 0, 1, 2, 3, 4, 5. If I started 5 here and I subtracted, which would be going this way, 8, where would I end up? I would end up at negative 3. And so the answer to this one is negative 3ab. The ab just tells you what it is, right? I mean, we gave a big square for x squared. Maybe you draw something for this. Suzer, that's my really bad looking baby. You have 5 babies. This is not good. This is not a good analogy. And you subtract 8 babies. You'd be left with negative 3 babies. Okay, maybe the example, it kind of fits because I've got 5 ABs, which is close to a baby. But that looks like, if that was someone's baby, I'd be like, ooh, your parents must be ugly. All right, we'll erase that. I'll go back to baby drawing school and work on that for next time. But you have 5 of something, in this case it was ABs, and you subtract 8 of that same thing, you'd be left with negative 3 of that. Are these like terms? All of them or only some of them? Okay. Is there one that's like with y? Yes. Would y be a like term with y? Yes. What about this y? What about 3y? Yeah. Yes. They all have a y in them. And so if you have 1y plus 1y plus 1y plus another 3 y's, what do you have in the end? You have 6 y's. Okay? You are now showing expert skills in algebra. Okay? And one of the things that many students hear is when they hear algebra, they start to think, ooh, this is when math gets hard, I'm going to stop paying attention. But in reality, you don't realize you've been doing algebra since you were born without knowing it. When someone had 2 apples and they said, here, have another 3, you're like, okay, I now have 5 apples. You did algebra without realizing it. You were comparing things that were alike and were different. If someone said, here's 2 apples and here's 3 oranges, you now have 5 apples, you'd look at them and go, no, you are not smart. 2 apples plus 3 oranges does not make 5 apples. It stays 2 apples and 3 oranges. Okay? That is algebra. In algebra, though, we just have letters that we're doing that with. Okay. Simplify. 7x minus 5x plus x. The first thing you have to decide, are these things alike? Hey, where did you have 2 more examples, don't you? Yeah. And mine are missing. So you have example 5 and example 6. I don't know where mine went. Try example 5 and example 6. I'll put up the answers in a bit. Oh, no, we'll do example 5 together. So example 5 in your notes is 4x squared minus 3x cubed. And you want to simplify that. Are they alike? No. No. So the answer is 4x squared minus 3x cubed. Right? You would just say exactly what you started with. It's like I said, if you have 2 apples and I give you 3 oranges, you're not going to say, oh, I now have 5 apples. You're just going to say, I now have 2 apples and 3 oranges. That's what I have. Nothing changes. So in example 5, where the things are not alike, you're already done the question. Which seems a little bit tricky, isn't it? You feel like you'd do something wrong if the math teacher said, simplify, and you're like, it's already done? Doesn't that feel almost like a little bit of a trick question? You would just write down the question again, and you would have got it right? Okay, example 6, though, I want you to try this one first on your own, which is minus 6m plus 4n minus 5n plus 8m. Oh yeah. 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 No. Oh yeah. No. Oh yeah. Where are you? Oh yeah. Oh yeah. Oh yeah. Should bring, if you know that you're going to get thirsty, you can bring a water bottle to class. But while we're here, have you done this one already? Have you written it down? Not yet. So we want to make sure that we're focused in class, learning as much as possible. So here, the 4n and the minus 5n are alike. The negative 6m and the 8m are alike. Okay, strategies students do. Some students take out different colors of pens, like I did, and circle like terms in different colors. That way it's really easy to see the things that are alike. Some students use different shapes, like If I was using the same color, if I only had my pencil, I might underline those ones and circle these ones. Or use squares or triangles so I can see which ones are alike and which ones are different. I think using different colors is easier, but different shapes works as well. If you have minus 6 m's and you add 8 m's, how many m's would you have? Think about your number line. It's just integers. Minus 6 plus 8 would give you 2 m's. If you have 4 n's and you subtract 5 n's, you'd be at negative 1 n. And you can just write negative n, or you can put a 1 in front. That is not wrong. But you don't need that 1 in front. Okay. Your homework that I want you to do is these ones right in here. Questions A to G, simplify them.